Okay, Lizzie, when you think of ketones, what do you think of?
Nail polish remover.
Which
has acetone in it.
Very good. Very good. Wow, excellent. And there was much rejoicing. All right, we'll talk about, but that's the other name I would have used for a band, though, the acetone. But it would have been a really cool joke because I would have spelled it the acid tones for like a punk rock band. You know, you get it? Huh? Even though it's really acetone, right? But and then of course the organic chemist in you would know that that's a takeoff.
You're hilarious.
You could be the ace tones.
You really are.
Anyway, okay, how do we name these guys? Very similarly to the way we name everything so far. First words almost always are name the alkane and all that that implies. And by the way, sometimes it says name the alkyl group, as you're going to see with the ether in a little bit. So this guy says name the alkane, though. All right, name the alkane and everything else that goes along with that. And then you just number where that carbonyl group shows up. Okay? Carbonyl group being the double bonded O. And then you're going to have to add a suffix. And then what do you think the suffix is going to be?
Oh.
Oh, right. So that says add own suffix, not add one suffix, which I always, what does this mean? Add one, just pick any one. As long as you don't add two, it's okay. Add one suffix. I actually got somebody, because, well, actually, you know when that happens? It happens for people who are absent. They copy the notes. They have no idea. They say, what do you mean add one suffix? What does that mean? Anyway, all right. So let's do that. Let's practice a couple of these. Example one. If I had to do this guy.
Why?
That was hilarious.
All right, what would that guy be? And this is your famous one. What would that guy be?
Acetone.
Exactly, but I know that. But what would his UPAC name be?
Nail polish remover.
Nail polish remover. Yes, that's using the exact system. Actually. First name the nail, then name the polish, then use the word remover. And you name every. It's amazing, but you name every. It's kept on the same way. What do you think his real name is?
Propon.
Propon. You got that. Right. No, it's not a propon. It's a what?
Harrison, you were right. You were right the whole time.
Right.
Wait, isn't it?
It's own, number one, and it would be the whole alkane. So you call it what? And you have to number it too. You're forgetting everything except for the mispronunciation of on. Own. What would I call this? Two.
Propanone.
Propanone. Exactly. See, this should be starting to make sense. Look, where else have we seen something that would be named similarly? Would it be surprising to call if that was an OH on there? If this were an OH on here, I would have called it 2-propanol. If it were a chlorine on there, 2-chloropropane. All right. If it was on here at the end, it'd be propanal. So that's how you name these guys. All right. They're all pretty much the same. All right. Propanoic acid. So if I say name the alkane, it means you name the whole alkane. All right, and then add the suffix. So propanone, not just propone. All right, propanone. Okay. Let's try one more. What would I call this guy?
Yeah, it's got to be the bloopers. That has to be.
I don't know if you can pick it up on the thing. But you probably can.
Say it later, Dave.
All right, what would that guy be called?
2
Right.
pentanone.
2-pentanone, right? All right, so everybody's okay with naming the ketones. All right. Oh, all right. Now let's talk about. Actually, it's funny. I don't actually have any reactions to do for examples. Look down on your paper here, and I don't even have them up here. At this point, first of all, there's two reasons I don't have it. One, ketones undergo almost the exact same reactions as aldehydes. Take a look at those two reactions you have there. All right? They're identical, with the only difference being the double bonded O is in the middle of a chain instead of at the end of a chain. Okay? So I'm not going to do an example of either one of those. I hope you can all look at those examples and figure out what you're going to do. Like, for example, for the oxidation of a secondary alcohol, the only difference is this. If it were an aldehyde, I have to use a primary alcohol, because then the double bond O would show up at the end, right? But for this, it's going to be a secondary alcohol. So notice there's an R on either side, and the double bond O, the carbonyl group, is in the middle of the chain somewhere on a secondary carbon. So therefore, when you form your carbonyl group over here, by the way, that should have been an OH here, not a, that's what you get over here, all right? You're going to have a ketone. Now look at, on the test for you guys Thursday, you're going to have that. Look at the similarity between that, this, okay? They're all very similar, but that guy's a carboxylic acid, that guy's an aldehyde, that guy's a ketone, and that guy's an ester. And you have to be able to tell them apart. It's not that hard. We've been doing these for a while, but the problem is, while you're doing one worksheet which concentrates on one of these, you're okay with it, but you forget about the other ones, okay? All right, let's do some, I'm not going to do reactions of these guys, but I am going to talk about ethers and do one really important reaction for that guy. All right, let's talk about ethers. First of all, a little bit about the properties of ethers.
Either this or either that.
Either or, which by the way is a great way to remember it. I thought I just
that is a great way.
either or, either or, either or.
That's a great way.
Or the ether bunny roars. Yeah,
I'm pretty sure
ether bunnies roar. You don't stipulate a night here at the ether bunny roaring. That's the problem. Okay, properties of ethers. They're highly flammable,
just like the ether bunny.
unstable over time. Just like the ether bunny. You don't piss him off.
He will explode.
He is. He was very unstable. He's had some real therapy. Very unstable. He forms peroxides.
He really hates kids.
Yeah. Those people are always stealing his eggs. They're his children, man.
He doesn't lay eggs. It's an Easter bunny.
No one said he would.
I didn't say he lays eggs. He carries them around in the basket.
He said that they are his children.
Well, they're like his children.
Full of candy.
I don't know.
Or money.
They're actually chocolate. There's no such thing as a bunny.
Yeah.
It's just chocolate.
Anyway,
I like bunnies.
so these guys are unstable over time. In fact, when I first came here, one of the things I looked for years ago, back in the Johnson administration, when I was hired, I looked for chemicals in the stockroom that I needed to throw out. And some of the stuff I needed to throw out, if I found an ether there, I would have got rid of it, because over time they form peroxides, and just opening the lid will make them explode. I could make them explode.
Whoa.
Very unstable.
So you open them just to...
So I checked every one of them by opening them. No, I got rid of them. I got rid of all the crap I had. I had tons and tons of organic chemicals that we should not have had in a high school lab. I mean, lots and lots of benzene and toluene and arsenic compounds out the wazoo. But I got rid. There was a couple other things too that I just too hazardous to have around high school kids. Another thing about ethers, they're often used as solvents. They're used as important solvents in organic chemistry. All right, and you'll use an ether most likely in a Grignard synthesis or in a Williamson synthesis in college. All right, so that's what I want to show you here in a minute. But first, I've got to show you how to name him. Nomenclature. How do we name these guys? There's actually two ways. Once again, I'm going to talk about the common system, because once again, you will see the common. Very few people call the smaller ethers by their systematic name. It's one of those guys that is rarely using the systematic name for the ones you use most often. Kind of like no one calls, I said ethanoic acid, he called it acetic acid. No one calls it methanoic acid, he called it formic acid. Same thing's true for these small ethers. How you name them, however, once they get larger, you can't name them by this common system. So I'm going to ask you to name them by the UPAC system, but I'm going to show you the other one. First of all, the common system, you would name both alkyl groups. Doesn't really matter. Just a shorter one usually first, but it doesn't really matter. And notice I said this time alkyl groups, not alkanes. Okay? And then you would add the word ether. So it makes it very easy to name. But it only works for really short ones, as I'll show you in a second. You see where you have example 1? Skip down under your notes a little further. You see where example 1 is there? All right, I want you to write this guy down underneath example 1. But then we're going to come back and rename them by the second method as well. So this does not go underneath the next thing here. I'm going to put notes there. You're going to put down under example 1 this guy right here. A very easy, oh, sorry. So easy I can't draw. Draw that guy under example 1. Okay? And we'll name him to the side by his common name, which is pretty easy. What would I call that guy if he were named by his common name? What are the two alkyl groups? Methyl, ethyl, ether. Yeah, methyl, ethyl, ether. Methyl, ethyl, ether, Lizzie.
You're saying ether, is it? Wait, no, just.
Methyl, ethyl, ether.
Oh, ether goes at the
Ether.
end. Oh, I thought ether.
You have to use that word at the end. Yeah, methyl, ethyl, ether. Sounds like I'm lifting. Which I am. Okay, so you write that down next to him. Methyl, ethyl, ether. For those people with a speech impediment, that's how you spell it.
You don't have to number this one.
Right, exactly. That's why you'll notice I can only use this system for very short ones because once I get, as I'm going to do in the next one, guy who's bigger than that, I have to number things. If I have a longer chain, all right, I'm going to have to tell which one of the carbons that O attached to. I don't have to for small ones like that. So here's my second way of naming the UPAC system. Or I could name and number. This is a little bit more complicated. Name and number the shorter alkyl group using an oxy suffix on that guy. That's a little bit more involved. Name and number the shorter alkyl group with an oxy suffix. OxyClean. That guy's dead, isn't he?
Yeah.
It's been a while.
You know, you don't bust that.
You're like Billy Mays.
He died
Billy
very
Mays.
early.
Yeah. And then you name the alkane of the longer group. Now, again, alkane this time. Alkyl group first, alkane second. And you treat him as if he were a substitution group. That's what you're doing. You're treating the shorter guy as if he were a substitution group. When I say that, here's what I mean. Watch. Well, first, let's go back. And you now have room for 2 examples here, right? So example 1, you already have drawn that guy there, right? And hopefully named him to the right. How would I name that guy? How would I name that guy? By this new system, by the actual system. The shorter one is the methyl, right? So I would call him methoxy, right? Methoxy what? Ethane. That's what I would call him. I would call him methoxyethane. Well, I'm going to write it up here so I have room down there. Methoxyethane. You see, here's why you need this system. Let me show you with my next example. So I say, well, why would I bother doing that harder system than more complicated one when I could just use methyl ethyl ether? As most of you have figured out, if I don't have to number in the first system because it was so small, it was so short. What if I had a guy like this?
Oh boy, here comes a.
So this would be example under example 2. All right, what I want you to do under example 2, you won't. It's kind of narrow there, and I'm going to make a larger compound. So why don't you draw him out to the side where you've got more room, and then we'll put the names underneath here. Okay? So draw him out here.
Sounds amazing.
Oh my gosh.
Dodeca oxycontin.
Oxycontin. Yeah. All right. That's why you had to draw him out to the side because he's a little bit bigger, and I wanted to do that on purpose. Okay? Now, here's what I mean by you're naming him as a substitution group. Watch. Treat the shorter alkyl group as a substitution group. Let me ask you this. If I drew this for you, everybody could have named this last chapter, right? You would have called this guy, but it doesn't really matter which side you ordered it from. Let's say 2-methyl 4-fluoro-pentane, right?
Yes.
Well, believe it or not, this guy's not named much differently. I have to decide which side to start from. I'll start from this side because it's got this thing on it. But treat him as if that whole thing were a fluorine or a chlorine or an ethyl group. I would call this guy 3-methyl, right? 3-methyl. What? Number the ether part. 2, what? Ethoxy, what? 4 long, the longest chain is 4. Butane, right. Do be careful. Some people say, well, isn't the longest chain, now watch this. Some people say, well, isn't the longest chain now like that? Why is that not the longest continuous carbon chain? Because there's an O in between it. It's not continuous, okay? All right, so I would call this guy, there's my longest chain. There's my butane part. There's my methyl part. There's my other substitution group, which I am calling, in this case, ethoxy, 2-ethoxy, okay? All right, that's basically how you name these guys. Okay, now let's talk about how we're going to make an ether. This is the only reaction I want you to know about ethers, and it's a really biggie.
It's C, not B.
Whatever. In your notes is correct, I'm sure.
Yeah.
I just have it wrong. All right, so your preparation of an ether is called the Williamson synthesis, and it's a really important one because, like you saw one time before, I went over it yesterday, the making of an ester. An ether is another way that I can link long carbon chains together. Like, for example, in an ester, you've got this. And you saw yesterday when I went over it with you guys, I did it today with the other class, I can go through some series of reactions to make that R group, a series of reactions to make that R group, and then put them together to make the ester, correct? Same thing's true for an ether. The ether, I will have to go through probably a series of reactions to make this R, a series to make that R, and then put the two of them together. That's what I'm going to show you. That's why these are great ones to ask on the test, because they're complicated and they require you to think. All right, go back and synthesize this from scratch, and usually taking 4 or even 5 steps to do it. Okay? All right, let's do this guy. The reaction looks like this, and it involves a guy we've seen before. I bet you don't remember him, but oops, this guy right here we've seen before. He is called an alkoxide, and both we had a fun time with that one. He's called an alkoxide.
Wait, and on what?
Yes. And so I have to take this guy and an alkyl halide, or a halogenated alkane, and add those two together, and then I join the 2 R groups. So let's try doing an example of that. All right? Let's do this guy. Oops. Look at this. I'm an idiot.
At least you admit it. At least you admit it.
It's fine.
Okay? Now, the hard part about these, I don't think, is seeing what happens. I think everybody can pretty much tell what's going to happen in this problem. All right? You can see that the R groups are going to come together, and the Na and the Cl are going to come together. But naming everybody can be a challenge. Let's put the 2 R groups together. In this case, it's pretty easy. What are the 2 R groups? They're both what? They're both ethyl. So I'm just going to write and the Na and the Cl come together, make NaCl, salt, naphtha. You can spell these phonetically, naphtha, naoke.
Do we get extra points on that? Napple. How do you say that?
Stutter. Sounds like you're stuttering. This ain't making it. Anyway. All right, what's the name of this guy over here?
One.
All we need is Phillips in here. That's exactly what he'll be calling all these. All right, so it's what, 1-chloroethane, or you don't even need the 1 in this case, but you know I'm not going to kill you if you put it there. Chloroethane.
As he comes in with that spatula.
Now this is the guy that's a little bit harder to name. What is he called? It's been a while since we've named these guys. Sodium ethoxide.
Yeah, there you go.
It's been a while since we've named those guys. That was not something we saw a lot of. Sodium ethoxide is how you would name him. And the reason he's harder to remember is that you're not using him like you've been using. For example, you've named these guys for a chapter for like a month, and it's just not. And you've named this guy all today. We've been learning how to name this guy, but this guy we haven't done in like a couple of weeks, and we only did it one time. All right, what is this guy's name actually going to be?
Which one do you want us to use?
Well, again, it won't matter which one you use. However, you're always safe by using the UPAC name. So what will this guy be by the UPAC name? Ethoxy ethane. If you were to use the common system, you would say ethyl or diethyl ether or ethyl ether. Ethyl ether. 2,2-diiodo-ethyl ether. All right, that's.
I think we can go teach in a foreign country now.
Yeah, well, we speak. Yeah, we speak Japanese here. We speak stutter. Chloral. We have many speech impediments. We have stuttering. We have lisping. Ethyl ether. I can teach anybody. All right, good enough. Good enough. Now, I will show you how to do one of these tomorrow. Actually, maybe by the end of the period today. I think that's what I'll be doing if you finish that.